Tonight, if sleep feels distant, let us gently explore one of the most mysterious ideas in modern physics. It is called quantum entanglement. You do not need to understand every detail. You do not need to solve anything. Just listen slowly. Allow the ideas to move softly through your thoughts. Quantum entanglement describes a connection between particles that seems to defy distance. Two particles can become linked in such a way that the state of one instantly relates to the state of the other, even if they are separated by vast space, even if one is here and the other is light years away. This idea once troubled even Albert Einstein. He called it spooky action at a distance, because it seemed to suggest that information travels instantly, faster than light, and that would challenge one of the most fundamental rules in physics. But let us not rush. Let us begin slowly. Imagine two tiny particles created together. Perhaps they form in the same energetic event. In that moment, their properties become connected, not in a visible way, not like two objects tied by a string, but in a deeper, mathematical sense. Suppose these particles have a property called spin. Spin is not exactly like spinning around. It is a quantum property that can take one of two values, up or down. When the particles are created together, their spins are linked. If one is measured and found to be spin up, the other must be spin down. If one is spin down, the other must be spin up. Before measurement, neither particle has a definite spin. Each exists in a superposition, a soft openness of possibility. But when one is measured, the other's state becomes defined instantly. No signal appears to travel between them. No delay is observed, just immediate correlation. This is entanglement. Let that idea settle. Two distant particles, connected beyond classical explanation, responsive to each other across space. It is not that they send messages. It is that they are described by a single shared quantum state, a unified wave function even when separated, as if distance does not fully divide them. Imagine two coins spun together and then carried far apart. While spinning, they are neither heads nor tails. Only when one lands does the other instantly correspond, not because it was told what to do, but because the pair was always one system. Quantum entanglement suggests that at the deepest level, separation may be less absolute than it appears. The universe may be more interconnected than our senses suggest. Let us continue gently. Let us continue slowly. Entanglement begins with interaction. When two particles interact closely, their quantum states can merge into one shared description. After that interaction, they are no longer separate in the classical sense. They are described together, not as particle A and particle B, but as a single system with correlated possibilities. This is difficult to imagine because we are used to objects having independent properties. A chair is here, a table is there. They exist separately. But quantum particles are not like chairs or tables. Their properties are not fixed until measured. Before measurement, they exist in probability. Soft distributions of potential outcomes. When two particles are entangled, those probability distributions intertwine. They overlap mathematically. They become inseparable in description. If one particle is measured, the wave function describing both collapses, and instantly, the correlated outcome appears in the other. No visible force connects them. No beam of light travels between them. Yet the correlation is perfect. This puzzled physicists for decades. Einstein believed that hidden variables must exist. some deeper layer of reality determining the outcomes in advance. He thought the particles must carry instructions from the beginning, but experiments were designed to test this idea. In the 1960s, physicist John Bell developed mathematical inequalities. These equations could determine whether hidden variables explained entanglement. Decades later, experiments were performed. Pairs of entangled photons were created and sent in opposite directions. Measurements were made at varying angles. The results consistently violated Bell's inequalities, meaning the correlations were too strong to be explained by hidden predetermined instructions. It appeared that entanglement was real, not an illusion, not incomplete knowledge, but a genuine feature of nature. And yet, it does not allow faster-than-light communication. No usable signal can be sent through entanglement alone. The outcomes are correlated, but individually random. You cannot choose the result of your particle. You can only observe it, and when you do, the other is instantly consistent. It is as if the universe preserves consistency across distance, quietly, effortlessly. Imagine standing beneath the night sky, two stars far apart, invisible threads of probability linking particles across the cosmos, not strings in space, but shared quantum descriptions. Space may separate objects, but at the quantum level, separation is not absolute. Entanglement suggests that the fabric of reality is woven together in subtle ways, ways we cannot see directly, but can measure with careful experiment. And in that measurement, we glimpse something profound. The universe is not just a collection of independent pieces. It is a network of relationships, a system of correlations, a tapestry of connection. Let that image rest gently in your mind, a vast cosmic web, particles responding to one another beyond classical distance, not chaotic, not violent, just deeply linked. And we are made of those same particles. Our atoms once interacted, once touched, once shared quantum states in the early universe. In some sense, Morty, the matter around you has a shared history, a shared origin, a shared entanglement long ago. And perhaps there is comfort in that thought. That separation may be less complete than it seems. Let us go deeper still. Let us move deeper into the mystery of entanglement. Imagine two entangled particles created together in a quiet burst of energy. They separate. Now one travels to the left, the other travels to the right, further and further apart, perhaps across a laboratory, perhaps across a city, perhaps across galaxies in theory. Distance increases. Space stretches between them. Yet their quantum description remains shared, not physically connected by a wire, not tied together by a visible thread, but united by a single mathematical wave function. This wave function contains all possible outcomes for both particles together. Before measurement, neither particle has a definite state. Each exists in superposition, and their possibilities are correlated. If one can be up or down, the other must correspond. But which is not decided until interaction occurs. Let us slow this down. Imagine a pair of gloves placed inside two separate boxes. You send one box far away. When you open your box and see a left glove, you instantly know the other box contains a right glove. But this is not entanglement, because the gloves were already defined. One was always left, one was always right. You just did not know. Quantum entanglement is different. Before you open the box, the particle is not already determined. It does not secretly carry the answer. It exists in genuine openness. Only when measured does it become definite. and the other particle instantly reflects that definition, not because it was pre-written, but because they were described together from the beginning. Experiments confirm this strange behavior again and again. Photons entangled and sent kilometers apart, electrons separated and measured in distant detectors. Even satellites have been used to test entanglement across hundreds of miles, and each time, the correlations remain immediate, precise, stronger than classical physics allows. Yet no usable information travels faster than light. The randomness of each measurement protects causality. You cannot control the outcome. You can only observe it, and observation reveals correlation, not communication. This subtle distinction preserves Einstein's relativity. Nothing is sending signals instantly. Instead, the system was always unified at a deeper level. This challenges our intuition about independence. We tend to think objects are self-contained, but entanglement suggests that relationships may be more fundamental than objects themselves. Perhaps particles are not primary. Perhaps connections are primary. The universe may not be built from isolated pieces. It may be built from interactions, from shared states, from relationships that persist across space. Let that idea feel gentle, not dramatic, just quietly expansive. Imagine the cosmos as a vast network of subtle correlations, invisible patterns linking distant regions. The early universe was dense and hot. Particles collided constantly. Entanglement was everywhere. As the universe expanded, many of those entangled pairs separated, carried apart by cosmic expansion. Though decoherence and interaction with the environment reduce observable entanglement over time, the principle remains. Connection at the deepest level. You are made of particles born in ancient stars. Those particles once interacted with countless others. There is a long chain of interactions stretching back billions of years. In that sense, the universe is a history of contact, a story of interactions unfolding, and entanglement is one of the purest expressions of that shared origin. Two particles, one description, separated in space, unified in state. Let that unity rest softly in your thoughts. We will continue gently. Let us step back now, slowly, gently, and consider what entanglement might mean beyond the laboratory. If two particles can remain correlated across distance, then space is not the whole story. Distance appears vast to us, miles, planets, light years. But at the quantum level, separation does not always break connection. This does not mean everything is magically linked in a mystical way. It means that the mathematical description of nature allows unity to persist across space. And that unity is subtle, invisible, yet experimentally real. Imagine a vast ocean at night. On the surface, you see individual waves, each one rising and falling separately. But beneath the surface, the water is continuous. One body, one depth. Entangled particles are like ripples on the same underlying ocean. They appear separate, but at a deeper level, they are described together. Perhaps the universe itself is like that ocean. What we call separate objects may be surface features, and beneath them lies a deeper unity. Physics did not yet give a final answer, but entanglement hints at this possibility. That reality may be more relational than solid, more connected than divided, more shared than isolated. And this idea can feel strangely comforting, because in daily life, we often feel separate from others, separate from distant places, separate from the stars. Yet the matter inside your body was forged in ancient cosmic events. The atoms in your cells were once inside stars. Those atoms interacted with countless others. Shared energy, shared states, shared histories. In that sense, separation is temporary. Connection is ancient. Entanglement reminds us that at the smallest scale, interaction is fundamental. Particles become defined through relationship, through correlation, through response. Perhaps reality itself is not built from independent pieces, but from patterns of interaction. Let that thought soften your mind. You do not need to grasp it tightly. Just allow it to exist quietly. Two particles. One shared state. Distance unable to erase correlation. A universe woven from relationships. Now imagine your thoughts as tiny particles. Some rise, some fade. Some seem far apart. But beneath them is one continuous awareness. One field of experience. Like entangled particles, thoughts may appear separate, but they arise within one shared mind. You do not need to measure each one. You do not need to collapse each possibility into a fixed conclusion. You can let them remain open, soft, undefined. Entanglement does not rush. It does not force resolution. It simply reflects a deeper unity. And as you lie there, perhaps in a quiet room, perhaps in the dark, imagine yourself as part of that cosmic fabric. Not isolated, not disconnected, but gently woven into a larger whole. Particles in your body responding to universal laws. Your existence arising from ancient interactions, from quantum events that began long before you were born. The universe is not distant. It is within you. And entanglement is one reminder of that subtle truth. Let the idea expand slowly, like waves spreading across calm water. No urgency, no sharp edges, just connection. Quiet connection. We will move toward rest now. Let us go even deeper into the feeling of entanglement, not as an equation, not as a debate between physicists, but as a quiet image in the mind. Imagine again two particles born together in a brief flash of energy. For a moment, they are close. Their states overlap. Their probabilities intertwine. Then they move apart. One drifts left, one drifts right. Distance grows, space stretches. Yet the mathematical description that defines them remains shared. It is as if the universe remembers their origin, not in memory like a human remembers, but in structure, in relationship, in correlation. This challenges the way we usually think about identity. We tend to believe that something is fully defined by itself. An object here, independent, self-contained. But entanglement suggests that some properties are not fully individual. They exist in relation. A particle's spin is not just its own. It may be defined together with another. A state is not isolated. It is part of a system. And perhaps this is not limited to particles. Perhaps, at deeper levels, reality is built from relationships first. Objects may be secondary. Connections may be primary. If that is true, then separation is more subtle than it appears. We experience ourselves as separate beings, separate thoughts, separate bodies. But the matter that composes us once interacted with the entire cosmos. Every atom in your body has traveled through ancient stars, through interstellar space, through countless collisions and interactions. At one time or another, those atoms were entangled with others, sharing states, sharing histories. Entanglement does not mean we can communicate instantly across space. It does not give us supernatural power, but it hints at something quieter, that the universe is not a collection of isolated fragments. It is a network, a web, a system of correlations extending across time and space. Imagine a vast tapestry, threads crossing and interweaving, some close, some distant, yet all part of one fabric. When one thread shifts, the pattern as a whole adjusts. not because information travels dramatically, but because the structure is unified. Quantum entanglement is like seeing one tiny part of that tapestry, a small glimpse into the deeper architecture of reality. And as you rest there, listening slowly, imagine that architecture beneath everything, beneath your room, beneath the walls, beneath the floor, beneath the planet itself. A quiet quantum layer, particles interacting, states correlating, probabilities unfolding, none of it chaotic, none of it violent, just subtle, just responsive, just deeply structured. The early universe was once an unimaginably dense sea of energy, particles constantly interacting, constantly entangling. As the universe expanded, those interactions stretched outward. Over billions of years, galaxies formed, stars ignited, planets cooled, and yet the fundamental rules never changed. Entanglement remained possible. Correlation remained real. Even now, in modern laboratories, we create entangled photons and send them apart, across cities, across continents, even between satellites and Earth. And still, the correlations appear, reliable, consistent, quietly astonishing. There is something beautiful in that reliability. Even in mystery, there is order. Even in strangeness, there is consistency. The universe may be more interconnected than classical physics once imagined, but it is not random chaos. It follows rules, subtle rules, mathematical rules, elegant rules, and those rules give rise to the world you experience. The bed beneath you, the air around you, the steady rhythm of your breathing, all emerging from countless quantum interactions, countless tiny correlations, countless invisible relationships. Let that thought slow your mind. You are not floating in isolation. You are part of a vast structure, a structure built from connection. Entanglement is not something distant and abstract. It is part of the same physical laws that allow you to exist. And in that sense, there is nothing alarming about it, nothing threatening, just depth. Just quiet depth. Imagine two distant particles once again, silent, separated, yet unified in description. Now imagine your thoughts as distant points of light in a dark sky. They may seem separate, but they arise within one continuous awareness. You do not need to chase them. You do not need to measure them. You can let them remain softly correlated, gently fading, gently aligning, no urgency, no demand, just quiet participation in the same universe that entangles particles across space. Let the idea of connection replace the idea of isolation. Let the idea of shared structure replace the idea of separation, and feel how the mind begins to soften. We will move gently toward rest. Now let everything become even slower. You have traveled gently through the mystery of quantum entanglement. Two particles, one shared state, distance unable to divide their correlation. Let that image soften. Two tiny points of light drifting apart in the vastness of space. No visible thread between them. No beam of light connecting them. No sound, no signal. And yet a shared description remains, a unity that does not strain, a connection that does not force. It simply exists. You do not need to understand it completely. You do not need to hold on to every detail. Let the science become a quiet background. Let the feeling remain, or connection, subtle unity, soft relationship. Imagine yourself resting in a dark room. The world outside is quiet. The air is still. Inside your body, trillions of particles move softly, electrons shifting between energy levels, atoms vibrating gently, molecules interacting in tiny, precise ways, all following quantum rules. all shaped by probabilities and correlations. And yet, you feel still, you feel solid, you feel whole. From uncertainty, structure emerges. From probability, stability appears. Entanglement is part of that story. Particles that once touched, once interacted, once shared a state, can remain mathematically unified even across great distance. They do not struggle to stay connected. They do not resist separation. They simply remain described together. Imagine your thoughts now as distant particles, some near, some far, some clear, some faint. You do not need to measure each one. When you stop measuring, the wave remains open. When you stop demanding answers, possibility remains soft, and softness can be peaceful. Perhaps sleep itself is a kind of gentle superposition, not fully awake, not fully dreaming, a quiet space between definitions, a place where thoughts do not need to collapse into conclusions, a place where possibilities can drift without urgency. Just as entangled particles do not rush to become definite, you do not need to rush your mind tonight. Let it remain open. Let it remain uncollapsed. Let it remain gently undefined. The universe has been unfolding for billions of years. In its earliest moments, energy fluctuated. Particles collided. States intertwined. Entanglement was everywhere. As space expanded, those interactions stretched outward. Galaxies formed, stars ignited, planets cooled, and through it all, the same quiet quantum laws persisted. The same subtle correlations, the same shared states, the same mathematical unity beneath apparent separation. You are made from that history. The atoms in your body were forged in ancient stars. Those atoms once interacted with countless others. Shared energy, shared states, shared quantum descriptions. In that sense, nothing is truly isolated. Everything has a history of interaction. Everything has participated in the same unfolding. Let that idea settle gently. You are not separate from the cosmos. You are not disconnected from its laws. You are an expression of them. Entanglement does not mean mystical telepathy. It does not mean instant messages across the universe. It means something quieter, that at the deepest level, reality is relational. Not just objects, but relationships, not just things, but interactions. And perhaps that is comforting, because relationships are not rigid. They are dynamic, responsive, adaptive, just as your breathing is now. Inhale softly. Exhale slowly. Feel the gentle rhythm. No effort, no urgency. Just a quiet exchange of air. Like particles exchanging states, your body exchanges oxygen and carbon dioxide. Subtle processes, invisible interactions, constant balance. And as your breathing slows, your thoughts can slow too. You do not need to chase them. You do not need to define them. You can let them remain softly correlated, softly drifting, softly fading. Two particles, one shared state, two breaths, one body, many thoughts, one awareness. Connection without strain, unity without force. The night is deep now. The laboratory lights dim, the detectors silent, the photons drifting. No more experiments, no more measurements, only quiet potential. Only calm, only rest. And as the idea of entanglement dissolves into something softer, as the language becomes quieter, as the mind becomes gentler, you can allow yourself to drift. Drift without measurement. Drift without collapse. Drift without decision. Only stillness. Only softness. Only sleep. And now, let everything become even quieter. The idea of entanglement can fade into the background, like distant stars slowly dimming before dawn. You do not need to hold on to the science. You can let it dissolve into a simple feeling of connection. a quiet sense that the universe is deeper than it appears, and that you are gently part of that depth. Two particles drifting apart, yet still unified. Two breaths rising and falling, yet part of one steady rhythm. Nothing to measure, nothing to solve, nothing to decide. Just softness, just calm, just the quiet unfolding of rest. And as the final thoughts loosen, as the mind grows still, you can allow yourself to drift fully now. Drift without effort, drift without thought, into deep, quiet sleep.